Hi everyone, and welcome to the first in what I hope to be a long series of Romhacking ASMR videos. It's always been my dream to combine my two loves, Romhacking and amateur ASMR content, and I finally decided that today is the day. So, without further ado, let's get started on making some Romhacking magic, shall we? Let's start up the game, go over to Final Burn Alpha IR, and boot it up. Of course, the first step to any great ROM hack is figuring out what you want to make. Now, I've already gone ahead and decided what we're going to make today. You can follow along if you'd like. Now, you may be wondering why I've selected Hall Horse and Boingo. That's simple. We're going to give Hall Horse and Boingo Hanged Man, if we can. Now, the first step, of course, is to figure out where the data exists for this. Now, I always like to start out with the sprite data, where the sprite data can be found. Take a note of it, usually in something like Notepad++. Let's go ahead and open that up. Create a new document. Shrink it a little bit. Now, in order to figure out where the sprite data is, you can do this a few ways. You can either search for it yourself manually, skim through every single sprite until you find what you want, or you can use the power of RAM addresses. Now I'd like to show that off for you for a bit. So, we know that the RAM address for player 1, the unit RAM address, is OX203488C. Now you've noticed my Google search results already show a few RAM addresses already. Sorry about that. Let me just pause the game for right now. Now, the one we're going to want to look for, well, there's actually two, I'd like to think. Plus OX68 for this one. Now what this is going to give us is the sprite itself. So let me just go ahead, go to Miscellaneous, and open up the RAM watch. Type in this RAM address. 2034, pardon me, 0348F4. We're going to want it to be in hex, and it's a 4-byte value. Click OK, and it's been added. And we also want plus OX90, because this will show us the frame data for the move. That yields us with 203491C. Let's open up their addresses. Let me go to Hall Horse actually. You want Hall Horse to be player 1. Otherwise, it's not going to work correctly for you. Because you need the player 1 RAM address. Or you need the, these RAM addresses give you are the sprites and frame data for player 1, not Hall Horse. Well, if Hall Horse is player 1, it does. So let's go ahead and input Hangman. But let's go frame by frame. Just so we can know exactly when it changes. And right there. Hanged Man frame data. OX6884148. And actually, let's shorten this a little bit. Just call it 214. OX6B8 28CC. Now, what we're going to want to do is switch over to the debug mode by changing the region to OX70 in hex. Now when you restart the game, I'll show you the development version. if you press light punch and the diagnostic key, brings you to the debug menu. Now there's two main editors you're going to want to use for this. Object, for finding sprites, and hit editor, for frame data. Go into Object, let's go over to Whole Horse, so we can make sure that what we got was correct. So we're looking for, right here, let me highlight it, if I can, 6B828CC. Goes in numerical order. If you press A, it'll fast forward through it. B is reverse. Let's speed this up a little bit with tab. 28CC. There you go. You'll find all the sprites. Now, if you go into hit editor, you'll find the same sort of thing. Unfortunately, it's not perfectly numerical order here, but it's close. Until you find Whole Horse. And I do want to take note for anyone curious. This jacket Dio here, this is in-game, but this is the boss Dio, the first form Dio you fight in the story mode. Not all the sprites are there, unfortunately, so you can't just directly replace it and have jacket Dio in-game. Sorry to anyone that wanted that. Just gonna have to wait, sadly. So we want to find 688-4148. And right here. And you'll see. That's the animation. But what are these numbers? 4, 1, 2, 2, 6, 6, 6, 6, 4, 4, 4? Well, aside from being the devil's number, these are how many frames that animation or sprite lasts for. So this one lasts for 4 frames before changing. If you go frame advance and use the A button or light punch goes through the animations normally. So you'll notice that's 1 frame, 2 frames, 3 frames, 4 frames, and it moves on. 1 frame. Now you might not be able to see that, but you're going to have to take my word for it. In any case, now, we need to find if Whole Horse and Boingo has the same sort of sprites that we can use. So I think we're going to want to go backwards for this in any case. Search backwards using medium punch, or B, in numpad notation. Because for Whole Horse, that Hanged Man animation was kind of at the end of his sprites. If we get to his normal attacks, we'll know that there are no sprites like that there for Whole Horse and Boingo. So I might have to find something else. Let's just tab it through. Right here you have the bullets, some dust effects, Boingo there. Bullets. Of course you have his frown. Spinning the gun. And it looks like we've gotten to his normals and we haven't found anything. So, excuse me for that. Looks like we're going to have to use our own sprites. Well, we're going to have to ad-lib this. Fortunately, I think I found something that might be pretty good to ad-lib. Skip forward a little bit. Right about here. Starting here. This finger waving seems pretty good. It's similar to taunting the opponent, which seems like the same sort of thing Whole Horse does with the Hangman. So, we'll start with that. So we'll call this Boingo and starting sprite. OX 6C5484C. Now, I do hope you'll excuse me for 1 second. I need to go cough out a lung. Sorry about this. It'll only be a moment. Sorry for the cut, but now I'm back and we're ready to continue working. So, now that we've found the sprites that we want to use in the frame data for Hall Horse, we're actually done with Final Burn Alpha. Now we switch over to MAME debugger. So of course you use the command MAME RR jojoban or jojoban, doesn't matter how you pronounce it, -debug. And here we are. Alright. So, now what we're going to want to do is find where the data exists in the code. And of course for that, we have yet another RAM address on our side to help us. RAM address OX 203488C plus. You'll notice it's the top result, 1BC. Forward, 2034A48. We're just going to want to set it to be 1 byte in length. We're going to want to set it for whatever that RAM address is read from, rather than written to, or both. And of course, when you start up, it's going to show it a few times. So we're just going to want to disable it quickly until we get to where we want it to be. Select Hall Horse. And enable the watch point. Now, we input the move, and it stops at that watch point. Now, what we're looking for is this JMP instruction right here. So we're just going to take note of that. (6077-298). Now, what that is, excuse me, is the address, if you will, the location in the game's code where the game handles, processes Hangman, if you will. That's where Hangman exists in the code. So, now, we could make it an entirely new move, add it onto Hall Horse and Boingo's moveset, but that's a little bit complex. And I want to keep things as relatively simple as possible. So we're just going to disable this watch point, restart, and find a move of Hall Horse and Boingo's to replace. Now, we don't mind. Just for example's sake, I think I've decided on which one is the simplest. Just because it's going to cause the least trouble. So, air glass. Not air glass, pardon me. Just regular glass. 623. So let's enable the watch point and input air glass. Now you'll see. Boingo. 623 is special data. Excuse me. Go over to the JMP, and you'll see OX 608 7580. Now then, as an example, let's go over to Xcopy. Actually, let's just make sure I have a fresh, clean ROM before I make any changes. Using this ROM here. Click and drag in the 10 and 20 files. Place them. And now let's open up Xcopy. Get another incredibly useful tool. Of course, for making the changes we want to see. Let up Judge open. Because it's file 10, we use offset 6 million, pardon me. I've never been too good with identifying numbers. It's one of my major flaws. But hey, everybody has problems. Well, maybe problems is a strong way of putting it. Everyone makes mistakes, everyone has little quirks. Make them who they are. In any case, what I want to do first is just show an example of what it would look like to immediately swap the data. So, let's search for Hoingo's 623. So we can use Control F, pardon me, as the main tool for this. But strangely enough, you're going to have to include the 0 at first. So 06, 08, 75, 80. Because if you'll notice, this is only 7 digits in length. And bytes are 2 digits. So if you neglect the 0 at first, it's not going to find it properly. You have to put in that 0. And then and only then will it be able to find it. So let's go ahead and swap quickly. 07, 72, 98. Save as, file 10. Open up our zip. Go to heritage. Click and drag this in. And reload the game. You'll notice an error, but that's okay. You don't need to worry about that. Oh, I forgot. Still need to unlock secret characters. There we are. Over to Hall Host and Boingo. You'll notice sprites aren't quite right. Neither is the palette. I do want to see if I can try command grab. I've never been good at it. Oh, right. Not quite that input. For a moment I thought I was playing Hall Horse. I'm gonna try going frame advance just to make sure. Okay. So it's just me being bad. I haven't been able to do command grabs too well, but anyway, there's a basic example. But let's try to add a little more complexity to this. Make this actually, you know, look correct. Because you'll notice, Hall Horse's sprites don't look right. Hanged Man doesn't really look right. Palette's all messed up. But at the very least, let's try to make Hall Horse and Boingo's sprites correct. Unfortunately, we're not going to get too far with modifying Hanged Man because, to the best of my recollection, though I may be wrong, it uses Hall Horse's palette. And of course, if we modify that, we're just going to screw with Hall Horse and Boingo's palette. So the regular Hanged Man uses Hall Horse's palette, so of course, it's just going to use the palette of whatever character it's on, which would be Hall Horse and Boingo. And unfortunately, that's going to screw with the palette for the character. Might screw with Boingo, might screw with regular Hall Horse, might screw with Hall Horse itself, or it might mess with the pipes. So, we're just going to try and aim to make sure that at least Hall Horse's sprites look correct. So, what are we going to do? Well, in order to do so, we're going to have to take the data and recreate it, copy and paste it if you will, so we can modify the code somewhat. because whatever sprite it uses or the frame data it uses is hard-coded in the move data right here. So we're going to have to copy that, paste it elsewhere. First off, 77298. Let's just find the next available sprite. Uses 607 7340. So we're going to copy from that range and paste it somewhere else in the ROM that has some free space. Let's type that in, 77298. And go until we see 77340. Awfully quick. You'll notice that a lot of these things start out with 2FE6, the data for moves. And the reason it starts off with 2FE6 is because that's actually a code instruction. Let me show you what I mean. Let's go into disassembly window and go to that address actually. 6077298. I'll see right here, 2FE6. And right here is the instruction it translates to. Move long value, so a 4-byte value, from R14 to the address at SP, minus SP technically. What that means is, takes the value at register 14. You can see the registers right down here. The value, of course, will change. It's not always the same. Registers are like short-term RAM addresses. They don't store, or they change much more frequently. They're the current bits of data the game has access to at any given point in time. RAM addresses are like the temporary storage that these registers pull from in order to make their changes. Now you have register 14, and then you move it into SP. But what is SP? That's actually register 15. And this minus means that it's taking whatever address is there currently, subtracting 4 from it, and taking the value at R14 and moving it into that address. If that makes any sense. You don't really have to know that for now. It's just a neat little tidbit. In case you ever want to further your ROM hacking knowledge, go down the path of ROM hacking. Anyway, let's copy this and go to some empty space in the ROM. Now, oftentimes I tend to use around 6280000, because that's where the free space kind of starts in this ROM. Now, it doesn't go on forever, but it goes on for quite a fair bit. Now, one thing I like to do is always make sure I started at that same sort of number as the previous one, or as the data I copied. You'll notice that it ends in 8, so I also want to have my thing end in 8. Why is that? Well, the code's a little bit finicky, you know? Heritage for the Future is not a very well-coded game. Of course, I think that's generally known. So, if you don't try and mimic it as closely as possible, it can get a little glitchy. A lot of errors come up, and it's just far more trouble than it's worth. Anyway, a simple strategy to know where you begin copying, where you begin pasting, and where you end pasting is just to paste right now. Then it shows you that end address, 62800AO. I'm just gonna undo, go to AO, or well, AF, mind you. Let's document where we put this, 0008. And let's change the pointer, just as a test. 6077298. found. Just wanted to make sure there were only two. And of course, because Hall Horse and Boingo follows after Hall Horse in the code, use the second one. So we're going to make this 280008. Go to File, Save As, save our changes. Drag in the file. Reboot FBA. Now let's test this. See if it works. Then from there, we're going to have to touch it up a little bit more. Guru meditation. Now, you may be wondering why that happened, and if that means this is impossible. Not so. Not so. Actually, I run into this issue quite a bit. Now, what that generally means is that it's trying to pull other nearby data that it can't find. Why? Because you took the ROM data and moved it to a spot that has no other data for it to reference. It's trying to reference data from other moves, other specials, but it can't. Because it uses relative location, not hard-coded location for those. So what's the solution? Well, go back in and copy a larger amount. Copy more than just the special itself. Let's go back to our data. Find this. So let's start at, instead, let's try OX607 70DO. All the way to 607 77C8. Alright. Looks good to me. Okay. Seven ODO. Let's start copying, and then once we're done, we'll start pasting. It's gonna take a while, but, you know, it's always worth it in the end. You know, a lot of the ROM hacking process can be kind of tedious, but I always think it's a rewarding endeavor. Finish a ROM hack, look back on it with pride. Oh, there we are. Done copying. And let's go over to where we were before. 8, 1, 2, 3, 4. Now as an example, let's see where we have to end it. 6FO. We're at 6. Be there before you know it. There we are. Now, you may be wondering, how are we going to find this address anyway? Well, that's what we can use the 2FE6 for. You know that 2FE6 marks the start of each and every one of them. Generally speaking, it might not always work out, but we're going to give it the benefit of the doubt for now. Well, maybe not. That's unfortunate, but hey, you know, it happens. Alright. 6077298. Let's actually find the distance between those two. OX6077298 minus OX6077ODO. don't think that's quite right. Let's see. Plus 1C8. There we go. That's what we were looking for. Plus 1C8. Let's add that offset in. There we go. C8. Now it's Command F. Sorry, Control F. If you're a Windows user, Command F if you use Mac. Not a lot of people use Mac though. I've noticed. 0008. And there we are, back at our address. 1C8. Now, should have a little bit more. Might not be perfect, but it's worth giving a shot. I don't know if it's gonna work actually, but you always have to try. Set up the ROM. Go over to Hallmarks and Boingo. Forward. And it looks like it worked. So now, we go to replace the sprites. That's where the frame data comes in handy. So, we already know where the frame data is. It's in the 20 file. So actually, I'm going to open up a second Xcopy for now, just to do this. Choke open. Because it's file 20, we use offset 6,800,000. Got it right this time. Let me drag this a little bit over. I seem to have some stigma against that bottom cursor. Never did anything to me, but just don't seem to like it. Anyway, let's go to that offset with the frame data. Where does it start? 84148. No, actually, I don't quite remember where this ends, so let me go back to the frame data and look for where it ends. Skip over a little bit, go through, 88, 41B4. Looks like I might have gone too far. Oh, no, never mind, not at all. Guess I did. Huh. You know, I've always been bad at navigating too. I guess it must seem like I'm bad an awful lot, huh? You know, guess I am. There we go. This down. So we know the frame data ends at 27C. Four two seven C. Oh well, 4290. 427C is the last address. Anyway, let's go back to more empty space in the ROM. All the way back to 628. Back with all that empty space. Now Good thing starting at 8. 4, 8. It's because it's easy. There we go. So now we just put Oingo OX 628 0748. You might worry that you're not able to put data from the 20 file in the 10, but actually you can. The data is read either way. The data is considered identical either way, really, is what I'm trying to say. Not always the best at conveying things. I can ramble quite a bit, but maybe that's one of my quirks. Well, anyway, now we gotta get to modifying the frames. So, let me go ahead and find this sprites, or these sprites that I liked. Right here. Actually, let me pull up a second copy of Final Burn, just to use as a reference. I think it'll make it a little bit easier. Sorry about having so many tabs. You know, Romhacking can be a little bit messy. Not exactly the cleanest process in the world, but I would say quite a fun one. There we go. 4148. Now, let me move this to the side of the frame data. Actually, as a little thing, let me check some of the hitbox and hurtbox data of this. See if it ever changes at all. Nope. Remains constant all the way through. Nice. Nice. Alright. That's good to hear. So, you see right here? This is the sprite that you're going to have to replace. So, see, the animation's actually the same at first. Replace that with Wingo's C5 484C. Then you go to the next one. C5 49B8. Are they the same? Let me double check. They are. So we can keep it right there. Actually, just copy and paste. Pretty nice. Pretty nice. I'm gonna want to look for the next thing. Why it's over in a different direction? Well, I'm assuming that's because the code will loop. If Hanged Man doesn't land, the animation changes, I believe. That's what it's accommodating for in the frame data. So we have C5, 4A, AC. 0, 6C5, 4B, 90. Change again. C5. Full C. 8-4. And again. Is that the last one for all? Nah, we got 2 more. So actually, let me copy paste, just so that we just barely make it. Now the next one. Now, you're going to want to take note of this. We'll get back to this soon enough, not to worry. Anyway, got 3 sprites left to worry about. We have actually, we're going to have to copy paste again. Starting to think. 2. It's 1, 2, 3. It's not going to look the best, but hey, you know. Romhacking ain't always the prettiest. It's kind of par for the course sometimes. Just gotta be happy with what you make. Then as you go on, you'll get better and better. Be able to make some incredible things. E5, 4E, 6C. Now, we're going to want to replace this actually, because this is a loop in the code, if you will. It's telling it to loop the frame data. Now, 4-1 AC, so that is the 4th frame on the list. So 1, 2, 3, and 4. 62807AO. Oh boy, debated color code. Not quite what I wanted to do. Now, there's actually one final thing I want to do, because hitboxes aren't always correct with these characters when you copy over the frame data. It doesn't use the hitbox or of the character whose frame data you copied. It actually uses the hitbox and hurtbox data of your character. And it's not always correct. So, I just want to make sure. If you look at the numbers here, oh boy. Let me just pause that tab. You'll see that the data is relatively, or you'll see what the addresses are in the data. Now, we're not actually going to modify any hitboxes and hurtboxes. I actually do want to check something, however. See if the data is the same for Whole Horse's standing sprites as it is for these. Because it never changes, actually, if you go through the whole thing. And it looks the same to me. Same as his idle. So all we gotta do, go over to Whole Horse and Boingo. Actually go over to the 20 file for his frame data. Replicate it. Or at least what defines his hitbox and hurtboxes. To be honest, I don't know the exact area, but you don't really need to. You just need to take a general area of it. Oh, geez. I make that mistake far more than I should. Gotta get rid of that 8. There we go. Oh, but actually, theoretically speaking, it's using the default data. So, it might be fine. Let's just pray for the best in this circumstance. Now, so one final thing we need to do in order to integrate this into the game's code. And that, pardon the car if you could hear it, will require us to use yet another RAM address, 3488C plus OX90. Again, 203491C. And we're going to wait for it to be written to, actually. Disable all watch points. Go over to Hull Horse. We're actually going to use the trace feature. So we're going to frame advance through. 3. Enable watch point 2. And then right before we input the move, we're going to trace and say hanged man frame data .txt. And we've already gotten our data. So now we trace off. Let's type this in. Let's edit this in Notepad++. So now we're going to look for the last instruction at that PC value right there, R5. And we see this instruction here. R5 moves into that RAM address. So now we want to see where R5 got that value from. And of course, see, the value at R5 is moved to R5. And where do we get that original R5 value from? From this instruction right here. So what we're going to do is set a breakpoint for that. Get rid of this watch point. We don't actually need it anymore. Disable that breakpoint. Stops at that breakpoint. Now we're just going to figure out what that R5 value is. 687 EC14. So let's go back to our 10 file in Xcopy. And actually, let me just create the address that we're going to use right here. 62808BO. Frame data. Is that 06280748. Let's just write that down. Anyway, now we're going to jump to that breakpoint 772E4 and find the earliest possible occurrence of that address. Oh, right. Silly me. Actually, let's jump to the correct thing instead. So that is at 2801C8. Pardon the notification if you could hear it. Guess I'm quite the social butterfly, eh? Now, let's search for this value. 0687 EC14. We found it. We found it. then what we do is now we replace it with our thing. 28 08 BO. Now, for what I'd like to call the moment of truth. The ROM. Pick Call Horse and Boingo. And now we see. Did it work correctly? More or less. Sprites for Hanged Man still aren't perfect, but fortunately, I'm not going to really fix that without direct sprite replacement and modification. And I would say that's kind of beyond the scope of what we're trying to do here today. But I'd say we've about got a finished Romhack, if you will. Fortunately, you can't sign it, as you would a painting, but you can take pride in the accomplishment. So, I'd like to thank all of you for sticking with me on this quite extended video. So, I wish you all happy Romhacking, and God bless, my friends.